Hello space enthusiasts! Today, we're delving into one of the most mysterious and intriguing phenomena in the universe, black holes. What are they, and why are they so fascinating? Buckle up, we're about to explore the depths of the cosmos. To kick things off, let's start with the basics. What exactly is a black hole? In simple terms, a black hole is a region in space where the gravitational pull is so incredibly strong that nothing, not even light, can escape its grasp. There are three main types: stellar mass black holes, intermediate mass black holes, and supermassive black holes. For a stellar mass black hole, imagine a massive star, much bigger than our Sun. These stars burn fuel, like hydrogen, to shine brightly. But when they run out of fuel, they can't support their own weight anymore. So, they collapse under the pull of gravity, forming a stellar mass black hole. Intermediate mass black holes are like the middle-sized siblings of black holes. They're formed in a similar way to the stellar black holes, but from a different process. Instead of a single massive star collapsing, it might happen when several stars come together, or when a star eats up a lot of material over time. Supermassive black holes are the giants of the black hole family, and they live at the centers of galaxies, including our Milky Way. Their creation is still a bit of a mystery, but one leading theory is that they form slowly over time by gobbling up lots of gas, stars, and even other black holes. Let's take a closer look at the anatomy of a black hole. A black hole consists of three key regions: the singularity, the event horizon, and the accretion disk. The singularity is the heart of the black hole, where all its mass is concentrated into an infinitely dense point. Imagine the weight of millions of suns crushed into a tiny space. The event horizon is the boundary beyond which nothing can return. It's the point of no escape. Once you cross this threshold, you're inevitably pulled toward the singularity. The accretion disk is a swirling, glowing ring of matter that spirals into the black hole. It emits intense radiation and can be visible from great distances. One of the most profound effects of a black hole is its ability to warp space-time. Think of space as a rubber sheet, and a black hole as a bowling ball placed on it. The bowling ball creates a dip in the sheet, causing things around it to roll towards it. This dip is what we call gravity, and it's incredibly strong around black holes. Black holes also exhibit a phenomenon known as gravitational lensing, where their immense gravity bends light and distorts our view of objects behind them. This can produce mesmerizing optical illusions, such as the Einstein ring, where distant objects appear as rings or arcs around the black hole. Gravitational lensing has been used by astronomers to study distant galaxies and cosmic structures. As an object gets closer to a black hole, the gravitational tidal forces become increasingly stronger. These forces can stretch and compress objects to extreme degrees. In the case of a star approaching a black hole, these tidal forces can lead to a process known as spaghettification, where the star is stretched into long, thin streams of matter as it gets closer to the event horizon. The powerful gravitational pull of a black hole can strip matter from nearby stars or gas clouds. This matter forms the accretion disk, a rotating, flattened structure of superheated gas and dust. As particles in the accretion disk spiral inward, they release enormous amounts of energy in the form of X-rays and other high-energy radiation. This radiation can be detected by telescopes and is a key signature of black hole activity. Near a black hole, the extreme gravitational field causes time to pass more slowly compared to distant observers. This effect, known as time dilation, means that time can pass at different rates for different people depending on how fast they're moving or how strong gravity is around them. One of the most groundbreaking discoveries related to black holes happened in 2015 when scientists detected something called gravitational waves. Imagine the universe as a big pond, and when heavy objects like black holes collide, they create ripples in the pond. Scientists built a special detector called LIGO to listen for these ripples, and they heard them for the first time in 2015. This was like hearing the universe's heartbeat and provided direct evidence of black hole mergers. Observations of galaxies have revealed that supermassive black holes reside at their centers. The discovery of Sagittarius A at the center of our Milky Way and the supermassive black hole in the neighboring galaxy Messier 87 are prime examples. These supermassive black holes are thought to play a vital role in regulating the growth and evolution of galaxies, as they influence the dynamics and distribution of stars in their vicinity. Scientists continue to come up with new ideas and theories about black holes. Some propose that there might be wormholes connected to black holes that could serve as shortcuts through space and time. In summary, black holes are some of the most mysterious and intriguing objects in the universe, and their effects on the cosmos are profound. They shape the very fabric of space-time, create mesmerizing cosmic phenomena, and have a lasting impact on the objects and matter that come too close to their gravitational clutches. Studying black holes continues to be a frontier of astrophysics, pushing our understanding of the universe to new limits.